Okay, so we've looked at sampling distributions, we've looked at confidence intervals, and we've looked at hypothesis testing, all for a one sample proportion. And now we're going to talk about what could go wrong. Now, we've been using this rejection region, which is the alpha level, right? There's a 5% chance of rejecting, etc., yada yada. Assuming this is true, blah, 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 right? Stats is all approximates and assumptions. Now, there are what we call types of errors and power when we are performing an inference procedure, and more specifically with significance testing. So, in general, if the null hypothesis is true, should we fail to reject it or should we reject it? And hopefully, since it is true, we want to keep that idea. So if the null hypothesis is true, then we should fail to reject the hoe. Now, if it's false, we definitely don't want that, then we should most definitely reject the hoe. So if it's true, then we reject. If it's true, we should fail to reject it. If it's false, then we should reject it. Now, what if we made a mistake? Then what are the possible outcomes? So let's suppose if we reject the hoe, given that it's actually true, this is what we call a type 1 error. And if we fail to reject the hoe, but the hoe is actually false, we commit a type 2 error. Now, essentially what's happening is you are flipping this dichotomy here. And why the cursor, there we go. So basically, we had this, right? This should have been the truth. But when we're committing errors, we are crossing paths here. So we have this handy dandy table here. So our outcome, right, is that either the hoe is true or the null is false. And to say that the null is true is the same thing as saying the alternative is false. And if the null is false, then the alternative is true. But again, in order to just not mix things up, we're going to just keep it all in language of the null hypothesis. And then based on our null hypothesis, we have the option to reject the null, reject the hoe if the p is low, or fail to reject the hoe or the null. I'm trying to decide which one I'm going to say. I'm like, for the sake of teenage sanity, I feel like I should be silly, but then for statistics, I feel like I should be proper. I don't know. I'm just going to change it up. Okay, so if the null is true and we reject the null, this is what we call a type 1 error. Now, if the null is false and we reject the null, we've made the correct decision, but this has a special name, which is called the power of the test. There's power in rejecting the false, right? Power in calling out the lies. Now, if the null is true and we fail to reject it, that's also correct. That's what we want. And then the last case is if we fail to reject the null hypothesis, but it's actually false, that's a type 2 error. So this table here just kind of helps us compute these errors and power here. And now it's easy to think that these are intersecting probabilities, saying that you reject it and it's true, you reject it and it's false, etc. But notice the key lingo here at the top. It says if. And back to our study of probability, we know that if means a conditional probability. So we're going to go down here. Each type of mistake would have a consequence. Deciding which consequence is worse depends on the context of the question. And you'll hear some statisticians say that the worst type of error is a type 2 error. False, because sometimes it might not be as bad as type 1. Everything always has a contextual component to it. So here's the probabilities here. So the probability of a type 1 error is essentially saying the following. So we reject the null. So we reject the null. However, the null is true. This is what we call alpha. So every time we reject alpha, every time we've rejected the null, we're actually committing a type 1 error. Now, suppose in the opposite case, what if we fail to reject it? So we fail to reject the null. However, the null is false. We're actually keeping the lie. This is our type 2. This is what we call a beta. And then the last one is the power. And in the power, we said we reject the null. And the null is false. So we're rejecting the lies. The way we find this is actually 1 minus the probability of a type 2 error, so 1 minus beta. These are helpful rules of thumb, but you will not be explicitly asked to compute these. You might be given the power or the type 2 and then asked to find the other one, and you just need to know that they are complements of one another, or some other concepts here which we're going to cover. Unless you're the 2018 question 6 from the FRQs, you bamboozled us all, but it's all good. We'll review that one in class as well. And here's just a helpful picture of our errors and power here. So a type 1 error is essentially a false positive. For example, telling someone with, I don't know how to go about this. For example, if we assume that both of these patients here were cisgender, and we're telling this guy that he's pregnant. We might have made a mistake there. If his biological sex is male, he would be incapable of having a baby. Now, or of carrying the baby. Lingo, important. Now, a type 2 error is a false negative. Let's say this mother here she's ready to pop, and we tell her, oh, you're not pregnant, don't worry. We can see there would be some consequences to both, right? Perhaps this male would spend money on unnecessary health visits and whatnot, and this woman might continue to live a risque lifestyle, but she shouldn't because she's got a baby. So that's just a fun visual for our errors here. Now let's look at some situations. So suppose that a potato chip producer and its main supplier agree that each shipment of potatoes must meet certain... Ooh, the hiccup. That alkaline water is working. They must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, the supervisor will inspect random sample of potatoes from the shipment, and the producer will then perform a significance test using the following hypotheses. So let's go ahead and create a hypothesis here. That 8% we're going to assume is our proportion. So we're going to do our null and our alternative. And remember, these are always in context of the parameter. So we were told that 8% is okay. So if the proportion of potatoes is 8% or less, we're good to go. Whereas if it's greater than 8%, we're in a pickle. So this here, P, right, is the true proportion of potatoes that have blemishes. So we're going to use an alpha level of 0.05. Now, some consequences here. If the potatoes are good to go, it's 8% or less, then they'll be turned into chips. Now, if it's 8%, or if it's greater than 8%, then it's just returned. So these are the consequences of these two hypotheses. So we've got our hypothesis ready, we've set a level of significance, we've identified the parameter, and we've talked about some consequences here. So now, let's suppose we commit a type 1 error in the context here. So I'm actually going to type these out as well. So as a reminder, a type 1 error is when we reject the null, but the null is true. So you reject a true null hypothesis, which is not what we should have done. So here, to reject the null would mean that we claim the potatoes with blemishes is greater than 8%, when in fact it is not. So that would be the type 1 error. Now what's a potential consequence? If we claim that the potatoes with blemishes is greater than 8 and it's actually not, well, we know that when we claim it's greater than 8, it's returned. So we would waste money on returning the potatoes as well as a loss of resources. So again, you just have to do this in context of the question. That's a type 1 type of error we could make here. Now, what about a type 2? And we're going to kind of continue this format here. So for a type 2 error, recall that when it's a type 2, we fail to reject the null. However, the null is false. So here, we claim the potatoes with blemishes is 8%, when in fact it is, when in fact it is greater than 8%. Well, this is a problem. So that's a type 2 error. And what's a consequence of this? We make a batch of chips with bad potatoes. Potatoes. And that's no bueno. Imagine giving out expired product or product that should not be approved by the FDA or legal. You might have some potential lawsuit consequences there. But in the grand scheme of things, the most immediate consequence is that we made a batch of chips with bad potatoes, and people are not going to be happy. Okay, and then lastly, the power of the test, and same thing here. For the power of a test, we reject the null, and the null is false. So here we claim the potatoes with blemishes is greater than 8%, when in fact it is greater than 8%. So we return a bad batch of potatoes. That's a good thing, right? There's always positive and negative consequences. So the power of the test and the correct decision would be what we originally stated. If it's 8%, we'll make it into chips. But if it's greater than 8%, we'll return it to the supplier. Type 1, we claim, and y'all, I've been doing this for a few years and I still have to kind of look back and see what I wrote, because if I just try and talk out of it, whoopsies. Here, we claim the potatoes with blemishes is greater than 8% when it's not, so we actually waste money on a return. Type 2, we fail to reject, but it's actually false, so we claim that it's 8%, so we're good to go, and we make a bad batch. And then the power here, we claim that it's more than 8%. It is, in fact, more than 8%, so we return a bad batch of potatoes. We're paying what we need. We're paying for what we need. So that's just some examples there of describing the types of error and the power of a test. And in the next session, we're going to talk more about the power of the test.